Move on, let's talk about some of the naming conventions. Class names are initial capitalized. So if our class name is, for example, if it's camel case, well, each word that is part of this class has its first letter capitalized. Variables and method names are in lower class. So if my class was called circle, we say class circle with C being in capital. Now moving on, let's talk about how we initialize or define instance variables. Now instance variables are declared within the init method. If you remember from the earlier example of circle, init is a dunder method. It's followed and it's preceded by double underscore, as you can see here. Now if you see in this particular case, I have again used the self keyword, and as I mentioned earlier, the self keyword is the first parameter of all member methods. And this basically binds that particular method to the particular instance itself during invocation. So every time a new circle object is created, the .init function sets the initial state of the object by assigning the values of the object's properties. So the init function basically initializes each and every new instance of of our class. So we can give init any number of parameters, but the first parameter must always be a variable called self. Now when a new class instance is created, the instance is automatically passed to the self parameter in init so that new attributes can be defined on the object. Inside the init method, the self.radius basically means that we want the value of radius based on the current instance itself. So as you can see, radius defines an instance variable radius, and we're going to use the particular instance and its value for radius in our variable radius. Now the init function is not a constructor, but it is an initializer to create instance variables. The init function also will never return a value, and it is optional and can be omitted if there are no instance variables. Now let's move on to class variables. So now, as we mentioned earlier, all the attributes that are created inside the init function are instance-specific attributes. And the instance attributes are obviously specific to a particular instance of the class. For example, all dog objects. Now, if we have a class called dog, then all dog objects have a name and age, but the values for the name and age will vary depending on which dog we are talking about, or basically which instance of the dog are we talking about. Now, class attributes are attributes that have the same value for all class instances. And we define a class attribute by assigning a value to a variable outside of the init function. So if you look at this example over here, we have created another class called circle, and we have this initializer again, where we have a class specific variable called radius, whose value will change depending on whatever we pass for that particular instance. However, if you look before the init function or the initializer function, if you see here, we have another variable called shape object, which stores the string circle. And this variable is going to be the same and constant for every instance of the class circle. And unlike the variable radius, we will not have different values depending on a particular instance. Okay, now let's talk about instantiating an object, and let's see what happens when we create two different instances of the same class. So as you can see here, I've created an instance C1 for class circle, and I'm going to check its ID. Well, if you see, the ID is something like this. Now, if I created another instance over here called C2, and if I check its ID, well, it's something different now. So if you see, each instance basically has a different memory location in our memory, and this is how each instance is different each time we create it, and they are created in different memory locations. Finally, before we conclude this topic on the introduction into OOP, let's talk about class methods, instance methods, and static methods. Now, class methods are actually declared with the @class method operator or decorator, as you can see here. It accepts the class as its first argument. So in this case, I'm going to define a class called myClass. I'm going to use this @class method decorator to say that whatever follows here is going to be a class method. And I've defined a class method called hello that takes in that uses again self and a name attribute. So what this does is it prints whatever I have passed to it in the form of hello from self.name. Now what this is going to do is basically it's going to give out a string saying hello from name of the whatever class we have and whatever we pass in the attribute name. So in this case, I'm going to invoke this method using the class name itself. I'm not going to use an instance name because I have no instance in this particular example. And since this is a class method, it can be invoked using the class name itself. So I'm going to pass Rakesh, and let's see what happens when we do this. As you can see, the first print will basically give us the information of the class itself. It's saying that the class is called my class, and the second print statement is basically a string saying hello from the string name my class with a comma and then whatever we passed initially, which was Rakesh. Next is then instance methods, and these are the most common types of methods. These are invoked by an instance object. So we have to create an instance to actually use an instance method, and it takes the instance or the keyword self as its first argument. So if I say if I define a class my class in this example, and I'm going to define another function called hello. As you can see, I have not used any decorator like at class method. So this is going to be an instance method, and it's going to be invoked by the particular instance. So in this case, it's going to print hello from, and it's going to basically say the name of the class again. So I create my instance called my instance1, and it's an instance of this class. And then I'm going to invoke the instance method by using this dot operator and the instance name. And the result will be basically this string over here, as you can see. Now finally, we have another type of method called the static method, which is declared using the addStatic method decorator. So a static method does not know its class and is just attached to the class for convenience. It does not depend on the state of the object and could be from a separate function of a module. A static method can be invoked via a class object or an instance object. So if you look at this example over here, I have defined a static method. I've defined hello, and it basically says print hello world. So it's going to basically just print this. So if you can see here, I created my instance and I'm going to say dot hello. It should basically print hello world. That's all. In this video, we will continue that discussion on OOP with inheritance. Inheritance is used to describe the relationship between two classes, wherein one class takes the methods and properties from another class. In this relationship, we have something called the base class or the parent class, from which we will derive all or some of the properties and methods. And the class which actually derives these properties and methods is known as the derived class. So you can think of the derived class as a specialized version of a base class. To explain what inheritance is in a basic way, I will show you an example where I'm creating a cylinder class, which is going to be a subclass of the circle class that you might have encountered in the earlier video on OOP. So what we're going to do is create a cylinder class that is a subclass of circle, where we're going to get the attributes radius and get area from circle class, and we're going to add the attributes height and get volume to the cylinder. So right off the start, you can see we have our class circle that you might have seen in the earlier video. So this class circle has the familiar initialization where we are supposed to enter a value for a radius that gets stored in self.radius. Now we also have a description string, which basically is a dunder method that returns a string when we invoke the print command on a particular instance. And we have the getArea method as well. Now if we move on to the cylinder class, you can see that I'm defining this class with the class keyword with the cylinder name, but you can see that I have added a parenthesis, and within it I have mentioned the name of the superclass that I want the cylinder class to be a subclass of. So this is how we actually define a subclass in the most basic way. You enter two different attributes for our cylinder instances. Now if you see here, there's a line which says super.init. Now this is like this is a command which we use to invoke the superclass's initializer. So anytime we create an instance for cylinder, we also want an initialization for the circle method as well as a part of our cylinder instance. Next, you can see that much like how we stored the radius attribute in self.radius, we're also storing the height attribute in self.height. Now even this cylinder class has an str method to return a particular string if we use the print function. And finally we get on to a new method that we have defined only for the cylinder class called getVolume. Now if you see the getVolume, it returns us basically the volume of the cylinder that is being described in the particular instance, for which we enter the height and the radius. So if you can see here, what we basically added extra is a height attribute and another method called getVolume. And the other parts of the circle superclass, such as radius and getArea, are also going to be a part of cylinder, even though you do not explicitly see them anywhere here. And we will see how. in the form of an example that's coming up. So let me just execute these classes. Now that that's done, I'm going to create an instance for cylinder. I'm going to store it in cy1, and I'm going to pass 1.1 for the radius and 2.2 for the height. And once that is done, let's just print to invoke the str method. And as you can see, the str method basically tells us the information that it's a cylinder with radius 1.1 and height 2.2. So now let's print what is the value we get when we use the getArea method. Now it's important to note getArea was not explicitly defined in the cylinder subclass, but it's a method that is a part of the circle superclass. And we can see that we can actually access methods that are part of the superclass simply by accessing any other method. So if we use the .getArea, you can see that we get a value for the area of the cylinder. So this area is basically the area of the circle face of the cylinder, the top or the bottom. Now let's invoke the subclass specific method, which is the getVolume method, in a similar manner. As you can see, just by invoking this method, we get the volume as well. Now, if we want to see what is the radius and the height, we can just do a simple print statement followed by cy1.radius, cy1.height, and it gives us both of these values, as you can see here. Now over here, what I'm going to do is create another instance of cylinder, but I'm not going to pass anything for radius or height. So basically, it's going to take the default values for radius and height, which was 1 and 1 respectively. So once I print, this statement is basically going to print the str method, or whatever we stored in the str, which is basically the description of the object followed by what is its radius and height. This method will give us the area, and this method will give us the volume. So once I execute this, as you can see here, this is what we get, and this is what we expect as well. So now in this example, what I'm going to show you is now I'm going to go back and I am going to create another instance for circle. Now this is the superclass, of course, and I'm going to give it, and since the superclass has only one option, one attribute that we can enter, which is for the radius, so I pass 3.3, and I'm going to print what happens when I just print this instance. It's going to basically give us whatever was a part of the str method. After that, I'm going to print isInstance. This is basically a check on whether C1 is an instance of this class circle, and next I'm going to check if C1 is an instance of its subclass cylinder. Now when I execute this, you can see that this is what this is the str method that gets printed. But if you see here, you can see that it says C1 is indeed an instance of circle when it says true over here. But when we look at the next line, is C1 an instance of cylinder? It says false, and this is obviously because a superclass object is never an instance of a subclass object, whereas vice versa, it would be true. Now in the next part of this video, what we're going to do is look at the different types of inheritances in Python. So there are basically 5 types of inheritance in Python. There is the single inheritance, there's multiple inheritance, multi-level inheritance, hierarchical, and hybrid inheritance. So we will go one by one and see each of these examples. Starting off, we have the single inheritance. This is simply where we have one base class and one derived class from that base class. So this is a simple single inheritance. And in this example, you can see I have a class called country, where I have a method that I've defined called show country, which is basically going to say print this is India. It's basically going to go print this every time we invoke this show country method. Then we have a class called state, which derives from the superclass called country, where we have a method called show state, which is going to say print this is state every time. So you can see I created an instance of the class state, and through that instance I can access the superclass and the subclass methods over here. Next we have the multiple inheritance, and this is when a derived class contains more than one base class. So let's look at an example to understand this. So if you can see here, I have a class called student with 2 methods defined called method 1 and method 2. In method 1, we can pass 2 attributes, SN, SNO, or I think this is supposed to be like an ID, I guess, like SN number, and we have S name. So this is basically 2 attributes we can pass that are probably descriptors for a student. And in the next method, you have basically 2 print statements which says student number, and then they will print the student number, and it will also print the student name. Next we have a class called marks. This is also so these 2 classes are basically what our super classes are going to be, and we're going to derive a third class from these 2. So this second class is a class called marks, and we have two methods again. One method is called setMarks, which has the option of putting in two attributes, M1 and M2, both representative of the two marks, and we store them in self.mark1, self.mark2. The second method is putMarks, which is going to print the marks, namely mark 1, and then it's going to tell us how much marks are there in the first subject, for example, and another print statement doing the same thing for the second subject, or mark 2. Finally, we have a third class called result, which derives from two classes, marks and student, as you can see here. In my parentheses, I've passed in marks and student. Both are super classes, and our class result is going to derive from both of them. This is an example of multiple inheritance. And within this class result, I have two methods specific to this derived class called calc, wherein I'm going to basically calculate the total marks of the total marks, which is basically the addition of mark 1 plus mark 2, and then I'm going to have another method called put total, which is going to print me what is the total. So if you can see here, I have created an instance of this derived class called result, and I'm storing it in R. Then I'm going to access method 1, which is obviously a method from the first superclass called student, and I'm going to store, okay, so his name is, I guess, Lucky, and he has 60 marks. Secondly, then I'm going to do our setMarks, which is the method from the second superclass, which is going to set the marks respectively. So you have Lucky student, and his ID is 60, and he has got 50 and 60 marks respectively in, say, the first two subjects. And finally, I'm going to access the derived class method called calc. So this is going to do the sum. Finally, I'm going to also do our method 2, which is going to print our student number and his student name. Next, we're going to have put marks, which is going to tell us the what are the individual marks for mark 1 and mark 2, and then finally we're going to print the total marks with put total. So once I execute this, you can see here it says student number 60, student name Lucky, marks 1 is 50 as I written here, marks 2 is 60 as I passed here, and then total is 110, which is basically 50 plus 60. Our next type of inheritance is called multi-level inheritance. Now multi-level inheritance can be assumed as where you take a superclass, let's call it A, and you derive a class B from that class A. Now what if we derived a class C from B, and we kept doing this? So until, say, a class E. Now each of these steps is in its own an inheritance, but this whole relationship can be described as a multi-level inheritance. So let's take an example again. So this time I've defined a class called student, where I have defined two methods called setStud and putStud, or you can call it setStudent and putStudent. In my first method, I have two options of adding two attributes. Again, this is the student number, this is the student name. In my second method, I am going to print what is the student number and what is the student name. Finally, next we have another class called marks, which derives from the first class called student. This has two methods called setMarks, where I'm going to again get the option of adding two integers for M1 and M2, which is going to represent mark 1 and mark 2. And finally, I have putMarks, the method which is going to print mark 1 and mark 2. Finally, I have another class called result, and this, if you see, this derives from marks. Now, if you see this relationship, you'll notice result derives from marks, whereas marks itself derives from student. And this is an example of multi-level hierarchy. And even as a part of this third class, we have its own methods called calc and put total. Calc will calculate the total as we had seen earlier, and put total will basically print that total. And we're going to do a very similar operation. We're going to create an instance of this third class result and store it in R. Then we're going to do we're going to set the student details, his student number and his name. We're going to give him his marks 50 and 60. We're going to calculate what are the total. We're going to say, okay, now put the details of what is the student's number and name. We're going to also display his marks, mark 1 and mark 2, and finally we're going to display the total marks. So let's execute this. And if you see, it's basically the similar operation that we did earlier, but the only difference is in the earlier example, our third class result was derived from marks and student together. So this was an example of multiple inheritance, whereas in this example, the result class derives from marks and marks itself derives from student. So this is an example of multi-level inheritance. Finally, we have, penultimately we have as our fourth example of inheritance called hierarchical inheritance. Pardon my mispronunciation, it's hierarchical inheritance. So in this case, a base class basically will contain more than one derived class. So let's look at an example of what we mean here. So I have a class called 1 where I have defined a method called display, where what I'm going to do is I'm going to store self.x is equal to 1000 and self.y is equal to 2000. Then what I'm going to do is I'm going to print a statement saying this is the method in class 1, and I'm going to say after that I'm going to print another statement saying value of x is self.x, which is going to be 1000. Then I'm going to have another print statement saying value of y is self.y, which is going to be 2000. Finally, next I have another class called 2. This is going to derive from class 1, as you can see here. And in this class 2, I have defined another method called add. And in this method add, what I'm going to do is I'm going to first print a statement saying this is the method in class 2. And then I'm going to actually print the result of x plus y, which is 1000 plus 2000. Finally, I have another class called 3, and this is also deriving from 1. So if you notice, we have one parent class called 1. And from this one parent class, we're going to derive two different subclasses called 2 and 3. So this is an example of hierarchical inheritance. Now in this class 3, what I've done is I've defined a multiplication method. What I'm going to do is print, first of all, I'm going to print this when I invoke this method, that this is the method in class 3. Finally, I'm going to say, I'm going to print the result of x times y, which is 1000 times 2000. So if you see, I am going to create an instance of 2 and I'm going to create an instance of 3, and I'm going to store them in T1 and T2. Now since T1 is an instance of 2, so I can access its methods add and I can access its methods display. So I'm going to use T1.display, and even in T2, since it's a class, it's an instance of class 3 and this also derives from class 1, I can also access its method display, but now I cannot access add, but I can access multiply. So if you see here, I access add through T1 instance, since add is a part of class 2, whereas multiply is a method in class 3. So I access it in its respective instance, which is T2. So if you see here, now once I execute this, what you will get is basically the results. So first of all, it will basically display the method from class 1, which is a display method. It will display the values of x and y. And since I've done this twice from two different instances, it will basically show a repetition over here. Finally, I've done the addition, and since this is a method in class 2, it is going to say as much, that this is a method in class 2, and then it's going to say x plus y is 3000. And now multiply is a method in the third class, so it's going to say this is a method in class 3, and it's going to tell me what is the multiplication result. Finally, we have what is called hybrid inheritance, and this is a combination of multiple plus multi-level inheritance that you saw earlier. So let's again understand this through this example. So we have a class called student, where we have a method called setStudent. Again, two attributes we can pass here for student number and student name. Next, we have another method, part of the class student, called putStudent. So this will print us the student number and student name. Next, we have a class called marks, and this marks inherits from student. So we have a method in class marks called setMarks, where we can pass two attributes for mark 1 and mark 2 respectively. And as we had seen earlier, we also have a putMarks, which will display the marks for marks 1 and marks 2. We have a class called practical. This practical is basically another superclass. If you see here, since this does not derive from anything, it is a superclass on its own. And what it does is it has two methods, get practical, and we can pass an attribute for p1 here, and we store that in self.p1. And then we have an attribute for put practical, which will print us the practical marks, whatever we passed for this attribute in p1. Finally, if you see, we have a class called result. Now in this result, we are going to derive from marks and practical. But if you notice here, marks itself is a subclass of student. So this is an example of multi-level inheritance. Whereas since result derives from marks and practical both, it is also an example of multiple inheritance. So if you see, notice here, this is an example of multiple and multiple level inheritance, which is basically what we call hybrid inheritance. And as we had seen earlier, this result class will have a calc method to do a total of the marks. In this case, mark 1 plus mark 2 plus the practical mark P1. and we have a put total method which is basically going to print us the total. So now we're going to create an instance of this result, and through this instance of result we're going to first invoke the parent class method called setStudent, which is the second level parent, basically the student class setStudent method. So we're going to setStudent here. We're going to say 60 is the student ID and name is Ash. Then we have setMarks, which is again the second level parent, which is a student class, where we set the marks. Finally, we access this getPractical. Now, if you notice, getPractical is part of the practical superclass. So in this, we store the third subject, or the practical marks 100. Then we calculate the total, and we put first the student details, then we put the individual marks, then we put the practical marks, and finally we enter what is the total. So let's execute this. And if you notice, you will see here student number is 60, student name, and all the basically whatever details we wanted is shown over here. In this video, we will continue our discussion on object-oriented programming with the topic of polymorphism. Now, the term polymorphism in OOP refers to the ability of an object to adapt the code to the type of data it is processing. Polymorphism is one of the key concepts of Python, and it is also a built-in feature of Python. An example to get us started on polymorphism would be how we use the plus operator. We use the plus operator not only for arithmetic additions, but we also use the plus operator for stuff like string concatenations or joining two lists together. This example where we're able to use the plus operator for different operations is an example of polymorphism. To show you what I mean, I have basically done a simple addition operation here, where I'm adding two variables, number 1 and number 2. When I do it on integers, it basically adds 1 plus 2. Now when I use it on two strings, str1 and str2, which contains Python and programming, two separate strings, and when I use the plus operator on these, you can see what it does here. It forms one string containing both of these individual strings. So this is basically the plus operator showing polymorphism, and is one of the simplest occurrences and yet most common occurrences of polymorphism in Python. Another example of polymorphism would be through the length function. The length function in Python is something that we use a lot and over multiple data types. Depending on the data type that we use the length function for, we get a different value or a different sort of information from the length function. Now, if you see here from this diagram, when we use the length function on a string, it gives us the length of the string. When we use the length function on a list, it gives us the number of items. Whereas if we use the length function on a dictionary, it gives us the number of keys. So this is, well, another example of how we have polymorphism in a function. Now what we're going to do is look at the different techniques through which we can enable polymorphisms in our code. Our first example that we are going to look at is through method overloading. Now, method overloading in its traditional sense, where we can have a method with the same name, more than one method with the same name in the same class, is not exactly possible in Python. So if we have multiple methods with the same name in a class in Python, which may differ in types and number of arguments, are not allowed and not supported in Python. In fact, if we did something like this, where we created a method with different say types and number and arguments, but having the same name in the same class, then what Python will do is it will only recognize the last defined method, and it will not recognize any of the earlier methods with the same name. But we can simulate polymorphism through method overloading by using default arguments in a method. Now, for example, what I'm going to show you here is an example where I have a method called sum. Now, by default, it has three attributes that you can pass through this method. A does not have a default value, B does not have a default value, but if you notice, C has a default value 0. So this is a simple example where I'm going to show you that the sum method is going to be used in two different cases. In one case, we're going to simply add two numbers, and in another case, we're going to use the sum method to add three different numbers. So we have this class overload demo, within it a method sum, and I have three attributes. A and B are supposed to be given by the user since they do not have any default values, whereas C has a default value 0. So if you see here in my first case, I first of all created an instance called OD for the class overload demo, and what I'm going to do is I'm going to store the value of the sum of 7 and 8 in the variable sum. Now if you see here, I have not passed a third argument. So what this method is going to do is going to take the value of C as 0 by default. So it's basically going to do 7 plus 8. And it's going to give us the sum for 7 plus 8. And in the next instance, I'm going to give three arguments, 7, 8, and 9. So now C will be replaced by 9 instead of 0. And then I'm going to get the sum of 7, 8, and 9. So in this is not a very commonly used thing, but it's basically a method just to show you that we can actually simulate method overloading in Python by using default arguments. So I've basically shown you how the same method sum has been used to do the addition of 2 digits, and then in another instance is doing the addition of 3 digits. It might look very similar, but you'll basically notice that by having this third attribute C, I have a default value of 0. I have induced some form of polymorphism through method overloading. Now the next way that we can induce polymorphism is through inheritance, which is called method overriding as well. Now method overriding gives us the ability to change the way or change the implementation of a method in a child class which is defined already in one of its superclasses. Now if there is a method in a superclass, the method having the same name and same number of arguments in a child class, then the child class method is going to override the method in the parent class. So what we do is when a method is called with the parent class object, the method of the parent class will be executed. Whereas if we call the method using the child class object, the method of the child class will be executed and it will override the method in the parent class. So the appropriate overridden method is called based on the object type, which is an example of polymorphism. So let's look at an example to understand this. So we have a class called person, and we have defined what we're going to define the initializer is 2 attributes which we have to pass called name and age, and we're going to store them in self.name and self.age. Now we have a user defined method called display data, where we are going to print if this display data has been called through the parent called person. If it's going to be called through the parent class object, then we're going to print in parent class display method, and then we're going to print the name and age that we have entered. Now we have another class called employee, which is going to be a derived class on person. So it's going to so it's also going to have an initializer, and this constructor will basically what this initializer will have is it will have an constructor for the superclass, where we're going to do this the same initialization that we do in the superclass, but we're also going to store another attribute called ID in self.employeeID. And if you see here, we also have another method called display data, which is the same named method from person. But now if you see in display data, I have almost the same information. I'm going to print the name, I'm going to print the age. But if you see the first statement, I'm going to say, if I'm going to call this method from the employee object, then I'm going to say in child class display data method instead of in parent class display data method, to say that basically I'm invoking this method from the child class object. And I'm also going to print on top of the whatever I'm printing before, I'm also going to print the employee ID. So if you see here, I have created an object called person, which is an object of the class person with the information of name John and age 40. And then I'm going to display this. Now next I'm going to create an object called emp, which is the child class employee object, which is going to now have the same information of John for the name and age 40, but now it's going to have an employee ID. And then I'm going to store this in emp, and I'm going to display the data for this child class object, and we will see the difference in how the display data is differing from the earlier case. So when I execute this, you see in the first case it says in parent class display data method. So this display data has been called through the parent class object, and I'm only going to show the information of name and age. Whereas when I invoke this method from the employee class object, it's going to say it's going to specifically say that it's a in child class display method, and then I'm going to say the name, age, and also the employee ID over here. So this is the difference between how display data has been used in its parent and its child class, and this is basically the example of method overriding. Now our next example of polymorphism is going to be through operator overloading. And operator overloading is the ability to overload the operator to provide extra functionality in addition to its real or core operation. And operator overloading is also an example of polymorphism, as the same operator can perform different actions. The earlier example of where we use the plus operator for different operations is an example of operator overloading polymorphism. Now, when is operator overloading required? Well, anytime you want an operator to perform a different function for you in your custom objects, you would basically do operator overloading. Now, an example of this would be what I'm going to show you below. So if you see this class called point, it has an initializer where I'm going to store two attributes x and y in self.x and y and in self.x and self.y. Now I'm going to create one object called p1 where I'm going to create point 1 and 2. So you can think of this object as basically like a coordinate, x coordinate 1, y coordinate 2. This is one point, and another point called x coordinate 3, x coordinate 4. I'm going to call that p2. Now I want to print p1 plus p2. Alright. Now if I try to execute this, you will notice an error. It says unsupported operand types for plus, point and point. This basically means that plus does not know what to do when it's given an object of this type. It has no idea what to do. Whereas what we want it to do is add the x coordinate from this point and the x coordinate from this point. So we want it to do 1 plus 3, and we also wanted it to do this y coordinate plus this y coordinate, or 2 plus 4. And then we want to print basically like something like 4, 6, or the addition of the 2 points, or the vector addition of these 2 points. So this is what we want this plus operator to do, but the Python does not have any inbuilt feature for the plus operator, and we are going to have to basically do some operator overloading to create a polymorphism on this. So let's see how we can do that. So to do that, first of all, we have to understand that all operators in Python have internally defined methods to provide functionality for these operators. The operator or the special method to provide functionality for the plus operator in Python is the add method. And whenever the plus operator is used, we are basically internally invoking the add method. So these sort of internal methods that provide functionality for the operators are part of a bigger class of methods known as magic methods. And these magic methods are automatically invoked whenever its corresponding operators are used. So if we want to change the operation for the plus operator in this example, we are going to have to use the add method in this case. And since it's a magic method, magic methods are also are basically what we saw earlier in the form of dunder methods. So magic methods are going to be invoked using double underscore, a prefix and suffix to it. So similarly to how we defined an init method or an str method, we are going to also invoke the add method using the same double underscore before and after its name. So now let's see how we're going to do this. So if you see this class, I have now my class point, and I have the same initializer when I'm going to store x and y. Now I am going to define on this add magic method, I am going to override the normal functionality of plus, and I'm going to give it a very specific function where I'm going to say for two different objects, you're going to add its the first part or its so-called x coordinate with the other x coordinate, and the y coordinate with the other y coordinate, and you need to return this to me in the form of a similar object. So now when I pass 1 and 2 and 3 and 4, it should return me 4 and 6. As you can see here, I have basically done what I wanted to do by operator overloading. I have changed, or I have overloaded this plus operator using this add magic method, and I have created a new functionality for this add function for these 2 points 1 and 2, 3 and 4. Now I'm able to add 1, 2, 3, 4 in the way I wanted to. So now that you saw how we did operator overloading, I'm just going to show you a list of similar magic methods for different operators that we are familiar with. So the plus operator already we've seen has the add method. Then we have the minus operator with the sub method. And similarly, we have for all of these operations such as multiplication, division, we have its respective magic methods. These magic methods are again prefixed with 2 underscores and suffix with 2 underscores, and they are also called dunders in Python. So this is how we would do operator overloading in Python for whatever operator we want. Similarly, we can do this for like comparison operators and for unary operators as well. So look at this example now where I'm going to overload the multiplication or the asterisk operator. So I've again defined a class called point. I'm going to define an initializer where I'm going to store some attribute x in self.x. Now what I'm going to do is I'm going to overload the multiplication operator where I'm going to basically allow the this asterisk operator to multiply 2 objects from, like, for example 12 and 5. Usually I can just do a normal 12 times 5, but in this case my object is slightly different. My 12 is being passed through an object of a class called point, and 5 as well in another instance of the same class. Now when I want to multiply these class instances, like the multiplication operator does not perceive these class instances to be integers. So by default, it would not be able to multiply what we want to multiply. But when we define or we overload the multiplication operator within our class, it's now able to understand what to do using the attributes of these classes in its respective class instances. So it's able to say, okay, so I want this attribute from this particular instance P1, 12, and I'm going to multiply it with the attribute 5 from instance P2. Whenever I say P1 times P2 or P1 asterisk P2. So when I execute it, it will give me 12 times 5. Similarly, I can also do this for the greater than operator over here. So I have a class called person where I'm going to define an initializer where I'm going to pass name and salary and store them in self.name, self.salary. The GT method is basically the greater than method, magic method, and it's going to we're going to use this to overload the greater than operator. And now again, using this greater than operator, I'm able to basically say object 1 greater than object 2, and I'm basically able to check through this, and if object 1 is greater than object 2, it will basically tell us if it is true or false, or basically whatever like we want to know. So basically the print statement will check for object 1 dot name, and it will say earns more than object 2 dot name if in case object 1 is indeed greater than object 2. So when I execute this, you can see here, my first information says John is earning 4,500 of some units, Natasha is earning 6,000 of some units. So it will say John earns more than Natasha. Well, it's false because object 1 is not greater than object 2. So since 4,500 is not actually greater than 6,000. And this is the check that I'm doing by overloading the GT operator over here, where I'm returning the Boolean value of what is greater, self.salary or other.salary. Self being the first object in any comparison. So if I'm basically any comparison, if I'm doing 5 greater than 6. So what the GT will do is this will be the self object and this will be the other object. So this is what I'm doing over here. I'm checking self.salary with other.salary in the form of these objects. And it's basically the same way that we are able to do 5 plus 5 through these class instance objects that you saw earlier, or 12 times 5 that you saw earlier. So this is all examples of operator overloading in Python. In this video, we will be taking a brief introduction into what is a function. So a function in Python is a group of related statements that performs a specific task or tasks. Now, functions help break our program into smaller and modular pieces of code. And it's very good and very convenient to use functions to make our code organized and manageable, especially as our overall program grows larger. It also helps us to avoid repetition and makes the code reusable. So let's look at the basic way of defining a function. So this is a basic function that I'm calling fun_name. Alright. Now the rest of the function, or whatever the task is going to be performed by this function, will be written over here with an indent, of course, as a standard when it comes to Python. So I'm going to define this one something in triple double quotes. So don't worry about what this is right now. This is a doc string. Don't worry about what this means, and I'll explain it to you just in a short bit. Alright. Now the rest of the statement, the rest of it will obviously be what this function will do. Let's include a simple print statement. Alright. Let's done here. And let's call this. So of course, once you define the statement function, to call the function, you just have to use its name like this. This is how you call a function. So as you can see, when I call this function, it should print the statement hello. Now let's look at some of the like what happened over here. So we've used the keyword def to define a function. We give it a unique name, which makes it with which we uniquely identify this function. And also, once we've done this, we can give this function a particular header. It's called a docstring. So what this docstring is basically something that we include in triple quotes over here just after the def keyword. And this is like a brief. We can use this to give a brief give brief information into what our function is doing. So we can say this function performs addition, this performs subtraction, or whatever, like some basic information as to what our function does. So we can use a docstring for that. Of course, this is an optional thing. This does not have to be, we don't have to include this as well. Alright. But for the sake of this, let's just keep it here. After that, of course, rest of the function, will contain whatever task we want to do with it, and that will be indented. Finally, we can also include a return keyword. And what the return keyword does is, at any point you find the return keyword in a function, you immediately leave the function and you go back to where this function was called. Okay. So now let's see. Now there's also one more important component of defining a function, and that's parameter. Now if you noticed over here, within these parentheses, I did not include anything. This is like an empty parenthesis, opening and closing. What if I said A, if I included some A and B over here? So what this means is, whenever I call this function, I need to pass two parameters, A and B. These can be like strings or numbers or whatever. But now it becomes almost mandatory that I pass these two things for my function to work. So let's define a function where I'm going to add A and B. So instead of this print statement, let's do this. I create a variable C, and in that I'm storing A plus B. Alright. And then I return C. So you can use a return, and you can return certain like variables along with the return statement. So I'm saying not only return from this function, but also give an output or return an output called C, which is the addition of A and B. Now, how do we use this? Well, now instead of just calling the function like this, I'm going to include parameters. So I'm saying pass 2 and 3 to function name, where 2 will take the place of A and 3 will take the place of B. Alright. What will happen now is addition will take place and we will get returned the result. So let's see what happens now. As you can see, 2 plus 3, and I got the addition of 2 plus 3, and it returned me 5. So yeah, this was like a basic usage of a function and parameters. So of course, we can, if you want to know like what the doc string of a particular function does or says, you can use this statement. So let's say it's very important to like just keep a note in your while you're going through this or while you're learning that whenever we use some sort of a function which has double underscore, right? This is like a built-in command provided by Python within the Python library itself. So these are like built-in commands to check certain details. So I want to check what is the doc string, and this is how I do it. So let's do print. Let's print what is the doc string over here. This is a doc string. So this is basically what I wrote over here. I can change this to this, like this does addition, for example. Alright. Now this will say this does addition when I execute this line. So this is the way to check what is a doc string. Anyways, so now that you have seen a basic function or two basic functions that I defined for you and how we use them, what a parameter is, let's look at another concept that we call scope and lifetime of variables. So scope of a variable is the portion of the program where the variable is recognized. Alright. Now a parameter and a variable that are defined inside a function are not visible from outside the function. This is a very key thing. So if we define something within the function, we can only use it within this function, and we cannot use it once the function has already been executed, so as to speak. These variables and these parameters have what we call as local scope, since they are only recognized within a particular function. Now the lifetime of a variable is the period throughout which the variable exists in the memory itself. And it's very important to note that lifetime of variables that are defined inside a function are as long as the function executes. Once we return from a function, whatever we have defined within it are destroyed. So when we use a function, it will not remember the values of a variable from a previous iteration of a function call. So let's try to understand this example or this concept using certain examples. So out here I have defined a function where I'm going to create a variable my underscore var, my variable, and I am going to store the value 10 in this, and then I'm going to print. So whenever I call this function, I will always create this variable, I will store 10, and I will print the value of this. Alright. Now what I'm going to do is, I'm not only going to create this my var inside this function, I'm also going to create a variable outside. So you see there, now you might be confused as to, okay, how is the behavior going to be? Because outside the function, I have created my var with a value 20, but inside the function, I will always define my var as 10. Okay. Now I'm going to print. So what I'm going to first do is, I'm going to execute this function that I created initially, where I store the value of 10 in my var, and then I'm going to print the value of my var that was present outside the function. Let's see what happens. You can see two different things happening. So when I execute this function, it prints the value inside the function as 10. But when I print the next line, which says, okay, now get the value of my var, it actually prints a value of 20. And this is a very key concept, because what's happening here is when I initially call my function, within this function, it creates a variable called my var, and it prints the value as 10. And the moment my function has been executed, it destroys this variable. And the variable which contained the value 10 is of course now destroyed, and all we have is the my var that contains 20 from the outside. And when we print that, we get its respective value as 20. So you can also think of it like this. The my var that is present inside this function is different to the my var that we create outside. So the scope of the my var within this function is local only to this function. And once the function is executed, that variable is destroyed. Alright. Now let's look at another case, or the other side of this case, where say we're dealing with variables that have a global scope. How do we deal with them? So let's create a variable called myvar. Alright. And I say I store 100 in this. Alright. Now if I define a function, I've stored myvar. Let's say I define a function. Define underscore, say again, same name, where what I'm going to do in this is I am going to print the value of whatever is there in myvar. Okay, so let's do print value of variable is value stored in variable is. Okay, that's myvar. So let's see what happens when we do this. Let's call this function fun underscore name. See what happens here. So as you can see, the value, I stored a value 100 in myvar and I've called it inside the function. And this is because since I've defined it outside, I can use it inside as well. Now what if I try to change the value of this variable inside the function though? So let's see. If I did this, and now if I try to print, let's see, is this allowed? No, it's not allowed. In fact, I get an error. It says local variable myvar reference before assignment. And without going too much into detail, what it's saying is that the variable inside over here is still local to this function. And I have not defined this myvar as a global variable. So I cannot make changes to it within this function right now. And to change that, I can use the global keyword. What if I did global over here? So if I did global, and now if I said, okay, global myvar, and I declare this variable as a global variable. Now if I do this, now if I do the same incrementation, now let's see what happens when I'm trying to do this. You see, I get the value 101. This is exactly what I wanted. And that is because I've defined my variable to be a global variable within this function. So I can, in fact, make changes to it within this function. So this is how we use the global keyword and global variable. Also, just to make a quick note, there are three types of functions. The three types of categories in which we can divide functions. First one being built-in functions. These are the ones that are built into the standard library of Python. The other is user-defined functions. That is the ones which we define ourselves. And the third type is called anonymous functions. They're also known as lambda functions, and this is something that we're going to cover in a separate video. Now let's talk about the arguments that we pass in Python. So there are four types of arguments that Python user-defined functions can take. First one being default, the other one is required, then there is keyword, and then there is variable number of arguments. So the default argument is when, say, if I defined a function where fun underscore name, and I'm saying a comma b, right? But what if the user has not, say I want a default value of a and b each time when I use this function. So in the case where if, say, I don't pass a value for a and b, like this will always be used. So I can just say a is equal to 2 by default and b is equal to 3 by default. And then within this function, I will say c is equal to a plus b and then return c. So I do this, and if I say fun underscore name, and in case I don't pass any arguments here, let's see what happens. By default, I get the answer 5 because by default a is 2 and b is 3. But this is not fixed and I can always change this by passing my own values here, 5 and 6, and in this case I should get 11, as you can see here. Now the next type is required arguments, and when we are defining a required argument, we just simply do not use the equal to sign for the parameters over here, and this basically it makes it so that now anytime we call this function, we have to pass something over here. So now if I try to pass like this, I won't get a, I won't get a default value. Then that's because, well, there is no default value and it needs an A and B. So I have to pass it a 3 and say 4. Now it should give me 7, as you can see. The next type of argument that we'll be talking about are the variable number of arguments. So let's look at an example here. So what I'm doing in this particular example is I'm defining a function called mySum, where I'm passing some parameter called myIntegers, and I'm doing something out here. And what this does is, it will take the values of a particular collection of objects, and that's called myIntegers. And each value, I'm going to keep adding it to each other, and I'm going to result a particular sum. I'm just going to result the sum of whatever is there. So in this case, what happens is I'm creating a list 1, 2, and 3, which contains 1, 2, and 3, and then I'm going to print the summation of whatever is there. So it should give me 6. Now, the problem in this case is that each time when I'm going to perform this function, I have to create a separate list where I'm going to store these objects. But what if I do not know what exactly I'm going to pass here? What if I don't know if it's going to be a list of objects or what is it going to be exactly? Well, in that case, I can use a variable number of arguments. So it's like a variable keyword argument. So what we use here is a specific way of passing keywords, and we do it like this. So I say define my underscore name, and I use an asterisk. Now I give it any name. This can be args, this can be integers. It doesn't really matter what this is, but this is the key, the asterisk here, and this tells us that whatever we pass here is now, we're supposed to create an iterable out of this, and then we can perform whatever task we want. So let's just, since I've already created one here, let's see how I'm going to use it in this case. So as you can see, I'm creating a particular variable argument function over here, and I'm doing the same task. I'm just going to keep performing, I'm going to add whatever I pass over here. But now when I'm calling this function, I don't need to create a separate list as I did over here. I'm just passing all the numbers that I want to in the form of, it's pretty much like a tuple. So I'm just passing these numbers here, and what this function is going to do is going to create an iterable out of this, and then we're going to iterate over it. As you can see, that's happening over here. And I can keep, I can just keep so since I've done it for 1, 2, 3, and 7, the summation should be 13 in this case. I can add another number here just explicitly, just like this, and you can see the value will change. And that's because this is a variable, argument method of creating a function. Now the fourth type of function arguments is the variable keyword argument. So let's look at what is the keyword argument now. So I have defined a function here called the concatenate function, and let's see what I'm going to do with this. So in this, I have passed a keyword argument. I've said that, okay, this is going to be a keyword argument function, and what I'm going to do in this is I'm going to create a blank string, and what I'm going to do is I'm going to add or I'm going to concatenate certain strings that I'm going to pass to this function. So in this example, I have passed Python and is and cool and an exclamation mark, all separate strings. And what I'm going to do in this function is I'm going to join them together. And I'm going to create one whole string out of it. Let's see what's the result. Python is cool. So this is, so of course, if I had to add something else, like Python is say, cool, and say, I just wanted to say hello and say one more string. I can add it just like this. I don't have to define a fixed number of arguments. I can pass any number of arguments I want. And this works exactly the same as variable. In the only difference is instead of positional arguments, we're using keyword arguments over here. Hello, bye. This, it doesn't really make sense, but just to show you, as you can see. So this is how we use keyword arguments. In this video, we will be learning about exceptions. Exceptions are errors that are raised during the execution of a program. When an error occurs, Python generates this exception that can be handled, which avoids our program from crashing. Python has many built-in exceptions. However, we can create many user-defined errors or exceptions as well to catch whatever errors we're looking for in our program. So when an error occurs, Python interpreter raises an exception and stops the current process, and it passes it to a calling process until the exception is handled. And if this is not handled, the program will crash. Some of the built-in exceptions are IO error, in the case when a file cannot be opened, or import error, Python cannot find the particular module being imported. And there are so many similar, exceptions that are built in Python for the appropriate cases. Now, before we move on and see how we raise these exceptions, let's look at the difference between an exception and a syntax error. So for that, I will be using an example where I will be dividing something by the number 0. Now, of course, this is not possible. So let's see how Python handles this particular problem. Well, it raises what we call a zero division error. And this is an exception that is built in Python whenever we try to divide something by 0. Now let's look at the difference between this exception and a syntax error. So this is the same statement, except I'm going to add this extra bracket, which does not make sense syntactically in this. Now if I try to execute this, as you can see, we get a different type of error known as the syntax error. And it says the unmatched closing bracket. So this is what a syntax error looks like an extra bracket or a comma that basically makes the line unreadable to the interpreter in the first place. So the interpreter doesn't even get to the point where it needs to figure out that there's something being divided by 0.